Okay, today on the Woken Way, 1.3D, exploring functions using a graphing calculator. So this lesson is basically just how to use your graphing calculator to get the information from graphs and from functions. And we're just learning how to plug in, how to zoom, and all that kind of stuff in the graphing calculator today. So let's go ahead. Look at this. All the directions are right there for you. So first thing says, prior to graphing, press the mode button on the calculator and make sure it is in function mode. So if you go here, you're going to hit the mode button, which is this button right here. And then you are going to make sure it's in function mode. We do parametric graphs, we do polar graphs, and we do sequences and series, but we're not going to graph them. So we're going to start with the function one. It doesn't matter if you're in degrees or radians, but right now what we're making sure is that you're in function. So if you're not, you're going to scroll down till the word is flashing and then hit enter, and then it'll switch it to there. And then anytime you want to get out, like maybe you made a mistake or you can't get out, you can hit the clear button, or you can hit second and then the mode button and it'll bring up quit. Okay? Okay, so before we begin, sometimes these calculators that we use in our classroom are used by the other classes that do statistics. So what I want you to do is make sure that the statistic plots instead of the y equals plots are turned off. So hit second and then y equals. And just so you guys know, anything to do with graphing is right underneath the viewing window. This is called a viewing window. And so what we're going to do is make sure we go down to number 4. You can either hit the number 4 or scroll down and hit enter, and then it'll say plots off, and then you have to hit enter again. Moral with the story with the graphing calculator, when in doubt, hit enter, because sometimes things don't get done until you hit enter. So it says done, so it turned off all those plots. And then the next thing that we're going to do is we're going to go ahead and hit the y equals button. And you can see I have an equation in there. If I want to clear it out, I'm just going to hit the clear button and it clears it out. So this is where I would type an equation in. So if I wanted to graph x plus 7, which is linear because it's to the first power, the x's, and it's a line. So I would hit this button right here that says x, t, theta, n. Remember how I just showed you there were 4 modes. There was function, parametric, polar, and sequential mode. So we're using just the x. So we would just hit x and then plus 7. And then you can hit up here, because you want to see the graph, you hit graph. And there's x plus 7 in the graphing calculator for you. Some other things that we want to make sure we can do is zoom. So before we zoom, I want you to hit the window. So if I hit window, you can see that this says my window that I look at has an x of -10 all the way to a y of +10, and each increment that you see is scaled by 1, and the same thing happens with the y's. So I'm going to hit graph again and let you see what that means. That means that in the x direction, that's a -10, that's a +10, and each increment that you see, each little dot means 1, and the same thing from here to here. Okay, now this window is wider than it is tall, so it's kind of not to scale. It's not like the ones that we graph. If I want to see it to scale, then, or squared off, then I can hit zoom and pick number 5, z square. And it doesn't look much different than it did before, but now the spaces are all scaled properly. What happens when you hit window, look, is in order to get them to be scaled properly, it had to make the x's go from -15 to 15 and scale it by 1. So that's how it got it to be. So you can see how much wider it is than it is taller. So I'm going to go back to graph, and let's say, oh no, I zoomed and I didn't want to. This is a good one to know. Hit zoom, and then 6 is standard. If you want to do zoom 6, and that just takes you back to this window right here. So I'm going to hit the window button again, and you see what it did. So one more thing that we can do is, let me show you. Go ahead and hit graph. Here's that graph that we still have in there. And if I hit zoom, maybe I want to zoom in. I can hit 2, and then you'll see right there in the center of your screen, you're getting a flashing dot. You can move that dot to wherever you want to zoom. So maybe you want to take a look at this y-intercept a little closer to make sure it's at 7. So zoom up to it, but then that enter button, you got to hit it. And so now it's zooming and focusing on that part of the graph right there. Okay? So what I want to show you now is go look at your window. So hit window. Ah, man, look at that. See how they changed the scaling? So the minimum y value is now 4.5, and the maximum y value is 9.5. So that's like 4.5 and 9.5 right there. So maybe you need to get back to the regular viewing window. So remember, you can just hit zoom 6 and get back to the -10 to 10 one. Or if you don't want to zoom by the calculator special ratio, you can just actually type in like that. Now, I do want to point something out because I did type in a negative. When you're looking at your calculator, this button down here is the negative button, and this is the minus button. So if it ever says error syntax or error domain or error something, check to make sure. I think it's a syntax error when you use the minus sign instead of the negative, and vice versa. So if I was trying to type in x minus 7 and I use this button, it would tell me I did it wrong, or it would graph the wrong thing because it would think you were saying x times -7. So just be careful, negative, minus. So here I am, back here. And so we've changed the viewing window already. So if you need to zoom out, sometimes we need to zoom way out. Sometimes we're dealing with real life data. And so, for example, how far away is the ball? It's not going to be negative. So we might have to change that to 0. And we might have to change that to something ridiculous like 5,000. Usually when I change it to 5,000, if the scale is 1, you're just going to see a bar because the calculator isn't pixelated enough to put 5,000 little dots for you. So if you want to get a better estimate, it's better to scale it, maybe like by 100s. Then you can see it a little better, maybe even by 1,000s. So if I went back and I scaled it by 1,000s, I have 1,000, 2,000, 3,000, 4,000, 5,000. Okay, so again, to get back to my regular window, zoom 6. So this is what we just talked about with changing the viewing window. This is how you zoom in and zoom out. So we already showed you how to do that. You just hit the zoom button, go figure, to zoom in and zoom out. You hit zoom and then pick the one that you want. And then to get back to the standard viewing window, press zoom 6, right? Zoom standard. Okay, so now in our graphing calculator, how do we find our maximum and minimums? So first, you need to be unclear on what's a maximum and a minimum, and so those are the turning points or the absolute maxes. So in our calculator, because it can graph continuous functions, we'll be looking at the relatives and maxims and minimums, and then we're going to be finding zeros and then using the intersect feature as well, which is part of your assignment. So in order to do all this fun stuff, I think it's easier just to apply it to a problem. So if you go ahead and flip it over, we have a problem here. And this says negative 2x squared minus 10x minus 5. So we're going to go ahead and get that in the graphing calculator. So anytime you want a graph, you're going to do the y equals button. And I have that x plus 7 in there, so I'm just going to clear it out. I'm going to hit the negative button, and then 2, and then x is, remember, x is this one right here, and then squared. You have two options for squared. So the one that will work for any power is if you hit this caret button. So do you see that right there? Caret squared. If you have a newer calculator, it doesn't look like this. It actually makes an exponent for you. Just remember that you need to arrow over right to get out of the exponent. So again, to get out of the exponent, if you have a newer calculator, you just hit this right arrow key. The other way that you can do this is there's just a square button. Because it's a popular exponent, they have that, but they don't have to the third power or to the fourth power, so you would use the caret to get those up there. minus 10x minus 5. And then we are going to hit, graph. So go ahead and hit graph. That's this button up here. Remember, to plot and to graph, it's all up there. And then what we have is our parabola. So I have some steps for you real quick for when you're doing these. I'm just going to move this out of the way so I can write them down. So step 1, you're always going to want to make a sketch of the graph where you label the key features. And when I say key features, those are like your min and your max, your zeros, and your y-intercept. So those are, if you have those things, you can pretty much graph most functions that are continuous. And then your third step after you've done all that is to actually answer the questions in your problem. Okay, so what I'm going to do first, because it says to sketch first, is I am going to figure out how to find these points. So there's some things that we need to know. First of all, this is going to be a relative maximum, okay? And when I sketch it, I can see it's like between -1, -2, -3, and then 1, 2, 3, 4, 5, 6. I lost count. 1, 2, 3, 4, 5, 6, 7, somewhere between 7 and 8 maybe. So I'm going to kind of make sure that I get that approximately there. So between -2 and -3, 1, 2, 3, 5, 6, 7. So maybe like right there. I'm going to find that exact point. That's what this part is. Find the exact points. So maybe we need to write that. Find exact points. And I'm going to label them on my graph. But right now I'm just kind of picking. I need to find my zeros. So my zeros, another name for zeros is the x-intercepts. So I'll draw that in there too. So I have one between -1 and 0, and one between -2, -3, -4, -5. 1, 2, 3, 4, and -5. So I don't know if you can see that or not, but again, I'm just counting from here. And then as far as my y-intercept goes, to find my y-intercept, I'm just going to use my equation. Y-intercepts are when x is 0, so I just need to find f of 0, and I can do that mentally real fast and see that it's at -5. But, you know, maybe you want to use your calculator to do that. And the way that you can use your calculator to find the y-intercept, you know x is 0. So the cool thing about your calculator is if you know x, it can tell you y, but it doesn't work the other way around. Okay, so let me say that again. If you know x, it can tell you y. And the way that you can do it, there's two different ways. There is a calculate menu for the graph. So that calc right there means it's going to calculate something from the graph. We use it very often. So if you hit second calc, when we tell you x is 0, that's a value. I'm giving you an x value, so you can hit 1 and it'll pull up x equals, and you can type in 0, and then it'll spit out to you that y is -5, just like I said. -5, the equation confirms it. The other way that you can do that is if I just hit graph, just to get out of that, the other way you can do it is you can hit trace, and you can scroll around during trace and it traces your graph. But if you want a specific x value, you don't have to do anything but hit that x value. So I just hit 0. You couldn't see it, I know, but I just hit 0 on the calculator while I was in the trace feature, and then I hit enter and it'll tell me it that way. So again, two ways. The more, I would say, intuitive way is second calc, because we use calc so often, and then picking value. The faster way would be to hit trace and then 0. Okay, so Now that I have this point labeled, this right here is the point 0, 5, so I do want you to label it 0, negative 5. And then the next thing that we need to do is find our zeros. So to find your 0, this is what you're going to do. I just told you we use this a lot, right? So hit second calc on the viewing menu because we want it to calculate something from our graph, and these are all the really cool things your calculator can do, and we're going to do 1 through 5 I think some point in this chapter, and then 6 and 7 you'll do in calculus. So I'm going to pick number 2. Now your calculator can only calculate 1 0 at a time, so it gives you this left bound question. So what I want you to do is pick a number just to the left of your 0. So a number just to the left. So this is in between 0 and negative 1, so I'm going to type in negative 1. Okay, so that's the left bound. And you can see an arrow. If you have a newer calculator, it'll probably actually give you a line. That's pretty cool. And then a right bound. So pick a number just to the right, but not on. So I'm going to pick 0 and then hit enter. And then it says, are you ready for me to guess? And you're going to hit enter again. Yes, please guess. So there is my 0. So here's the thing. When we do things without a calculator, we get nice integers or rational numbers as our answers. When we do things without a calculator or with a calculator, we get interesting zeros. So I want you to round to 3 decimal places, okay? So we're going to 3 decimal places. So that's negative 0.564. So this point right here is negative 0.564, comma 0. And I think at this point we can see the shape is a parabola. Now, if you're looking at your graph on this paper and then looking at the one in the calculator and seeing that this one looks a little wider, remember that this is a square graph and this is a rectangular graph. I can make it look more like that if I hit zoom and then the square option is 5. So that looks more like ours. It doesn't matter for finding things which one you use, it's just your own comfort level. So I'll even find the other 0 in this mode right here, and I'm going to go second calc. I'm calculating a different 0, and yes, you have to do it for each and every 0. My left bound, so just to the left would be negative 5, and just to the right would be negative 4, and then I'm going to have it guess. And there it is, negative 4.436. And its y-coordinate is 0 because it's an x-intercept. Okay, so I have told you to label the y-intercept. We've done the zeros, and now we need to do the mins and maxes. There is no minimum because this graph goes down towards infinity, but there is an absolute / relative max right there. Why is it both? Because it is the turning point and it is absolutely the highest point. So second calc, and it's a maximum, so I'm going to pick number 4. And then you need to pick your left bound and right bound. So what 2 numbers just to the left, an x value just to the left would be like negative 3, and an x value just to the right would be negative 2. And then hit enter and guess, yes please, and there we go. So it's okay for me if you round that right there to negative 2.5. Now, I'm going to show you a different way to do that left bound, right bound, but you can always fall back on a number just to the right and a number just to the left. So I'm going to go back to this 0 real quick, okay? So left bound, right bound, and then hitting that second calc is basically what we've been practicing, but I do want to show you this trick. Another way to find a 0. So let's say I want to find that 0 right there. Instead of me picking a number just to the left, I can put my cursor to the left. So how will I know my cursor is to the left of the intercept? Here's the intercept right here. It's at a y value of 0. Up here it's positive, which means it had to be to the left, and then as it came down, that would be something to the right. So I can look at these numbers right here and these numbers right here. So It's a little counterintuitive for some people, so you can always do just to the left and just to the right and type in the number. But what I'm showing you here is just how to scroll. So once you're to the left, and I can seriously be to the left, like way over here. Why am I still to the left? Well, here's my intercept. There I am. Now, if I came all the way here to the left, how many intercepts are now that? There's 2. So you don't want to do that. Just pick a number to the left, hit enter, and then you can also scroll. And now, how do I know I'm just to the right? I was actually just to the right there as well. I'm not just to the right there. Do you see? Watch my sign change in my Y's. And then it might make sense. So when I'm to the left, for this particular intercept, my Y values are positive. And how will I know that I crossed and I'm past the intercept? Because now they're negative. So in order to go through 0, I have to have a sign change in my Y values, and then I would just hit enter, and then it'll give me that same one we got before. Now I do want to show you the other one real quick, just so that we see this. Now a number just to the left. Well, for this particular intercept, numbers to the left of it, which are x values this way, are actually starting off as negative. So I'm going to hit enter. When will I know I'm just to the right of it? When my Y values turn to positive. There has to be a sign change in the Y values if it's going to cross through a Y value of 0, which all x intercepts do. Okay? Then guess. And there we go. So make sure you hit that enter. You don't want to pick the guess option. You want it to say 0. Okay. So now we are going to answer our questions. First one. What is the domain of f? We can do this a couple different ways. First, look at your equation. Square root or denominator? No. So default, negative infinity to infinity. Also look at your graph. Is there any restrictions on how wide this graph can go? So as x is going to infinity and x is going to negative infinity, nothing's stopping it. So negative infinity to infinity. Now, for the range, the lowest point on the graph is negative infinity. What's the highest point, and can it equal? So it goes all the way up, and the highest y value is 7.5. So remember that domain is x values and range is y values. The zeros, we have them right there. We already calculated them. This is why I tell you to find those key features first and label them, because it makes filling this out so much faster. What is f of 0? F of 0 is the y-intercept, so that is just -5. Okay? Intervals on which f is increasing. We did this yesterday. Intervals of increasing from left to right, you go up the hill. So remember, this arrow down here is just emphasizing that this graph, as the x's are getting more negative, so are the y's. That's what that's emphasizing. So from left to right, I'm going up a hill from negative infinity to negative 2.5. And then I start coming back down the hill for the decreasing from negative 2.5 to infinity. And reminder, we don't ever do brackets on increasing and decreasing because those are comparative words, and you cannot be increasing at one point. It has to be related to another point. Now this one right here is hard for students. It says the values of x for which f of x is less than or equal to 0. So less than or equal to 0. So this is saying where y is less than or equal to 0. So I'm going to go to my graph. Here's y equals 0. Anything below would be less than or equal to 0. So I have it highlighted there. So less than or equal to 0 is going to be from negative infinity to negative 4.436, which is right where that 0 is. And because it has an equal to, that's why I have a bracket. And then it's going to be from negative 0.564, comma, infinity. Okay, so again, why does that make sense? If it was less than or equal to 0, that's these pieces of the graph that are either touching or below the y-axis. So those are the intervals. It's below the y-axis all the way up until I get here, and then it jumps up above, and then it goes below. So sometimes, here's a similar alternate question for that right there. So if I say alternate question, it might say the values of x for which f of x is just greater than 0. So if it just said greater than 0, it would be from here to here, but it doesn't say equal to. So at those zeros right there, it's not greater than or equal to, right? So this one is just saying, I'm sorry, it's equal to, but it's not just greater than. So for this one, if I gave you this question instead, where is it above? Well, it's above all the way here to here. So it would be from negative 4.436 to negative 0.564. And that would be the alternate question. So I'm just going to put a box around this because I don't have a different color highlighter, but that relates to the pink part of the graph. And then I'm going to put, just kind of highlight this right here to show you that's corresponding to the yellow. Students have a hard time with that one, so I just want to make sure you see above and below 0 when y is 0. And if it equals, then you have to put brackets at the zeros, and if it doesn't equal, then they're parentheses. Okay? Relative max or min and the numbers at which they occur. So you definitely want to say that it's a max, because you don't want your grader, if this was an AP test, to assume that you didn't know that that was a maximum. And it's 7.5 when x equals negative 2.5. So for this test, you're really going to have to study what's the notation that's appropriate given the question, and the way that you practice that is with flashcards. So here's another one, the values of x for which f of x equals 3. So for that right there, it's asking you this, where does the y values equal to 3? So I'm going to take a pencil for this one and draw a line at y equals 3. So 1, 2, 3. That's where it's at, right there. So there's actually two values where our equation, our graph, intersects y equals 3. So how do we find these? So the way we find them in our calculator is pretty cool. This is what we're going to do. Go into your calculator. Mine shut off, so I got to turn it back on. I am actually going to go into the y equals feature and hit 3. I'm going to set up a second one. So here's my equation, and here's 3, and hit graph. Hey, there it is. Now, remember, anytime we want to do something, we hit second calc, and look at that, option number 5, intersect. So when we do these intersections, since there's two, notice the calculator says first curve. It doesn't say left bound and right bound. What you're going to want to do in order to be able to get both of those points of intersection is to find the first one, get really close. So the first curve is the parabola, so I'm scrolling along the parabola. I'm going to get really close to that point of intersection, hit enter, and then now it says second curve, which you'll see if you scroll, it has now jumped to the other equation, y equals 3, and again, get really close to that intersection, and then it'll say guess, and then you hit enter. And it says when x equals negative 1, y equals 3. So what is the question? It says the values of x. So what's our x value here? It is negative 1. And let's go see what the other one is. So to do it, second calc, okay, and then we are going to pick option 5. And this time I'm going to get really close, just using my left and right arrow keys. I'm going to get as close as I can to that first curve right there. and then second curve as close as I can, which I didn't even have to move, and then guess, and it tells me the x value is -4. So my 2 points of intersection are -4 and -1. What I want to show you off to the side here real quickly is to tie this in. F of x equals 3. So what it's actually asking you to do is set your equation equal to 3 and solve it. So if this was my equation, I'm going to get one side equal to 0. So that means I'm going to do that, subtract the 3. And then I see a common factor. I'm going to divide it out because I'm solving. If I was just factoring and this wasn't equal, I couldn't do this, but because I do have an equal sign, I can. And then I'm going to t-chart this or factor it, and you will see that what you end up with is that when your function is equal to 3 and you choose to solve it with an equation, you get the exact same thing that you get from your graph, but it took a lot longer to do. So if you're allowed to use a graphing calculator, having that as an option is awesome. Okay? Next question says, is f even, odd, or neither? So also a review of yesterday, or 1.3c. If you don't remember that, you can check out that video. So I can tell from the graph that this is neither. I'm looking at this and I'm like, okay, remember, if it's even, it would have symmetry with respect to the y-axis. This doesn't. And then if it is odd, it has symmetry with respect to the origin. But just to be clear, if I wanted to verify my thinking, I could plug in -x and see if all signs stay the same, which would mean it would be even. If they all are opposite, which means it would be odd, or if there's change in both, then it's neither. So if we compare this to our original equation, the -2x stays the same, but this -10x and that 10x change signs, so it's a neither. And you didn't have to do this work if you could just look at the graph and be able to tell, but we're still processing that because it was yesterday's lesson. So, okay, example 2, the final example. By the way, I just want to show you guys right here. It does tell you how to use the intersect feature, how to find zeros, and how to find the min and max if you forget. Okay, so you have your notes there for you written out and typed up. Okay, example 2 says the path of a basketball is thrown at an angle of 45 degrees and can be modeled by this equation right here, where x and y are measured in feet. Find the maximum height of the basketball. Okay, so when a basketball is thrown, it's getting thrown from a height of 6 feet because the person throwing it is probably pretty tall. So there's its initial height, and it's going to get thrown, and then it's going to land on the ground. And it's probably not going to go beyond that. So this is one of those situations where, yeah, we can see it modeled by a parabola, but it has a restricted domain because you can't go negative and you can't go below the ground in most cases. We can come up with interesting situations where that would happen. So what I need to do is find the maximum point, which is right up there, and the way I'm going to do that is with my calculator. So I'm going to clear out the two functions just by hitting clear that I already had in there. And then I'm going to type in that equation that I see right there. So we have negative, don't forget that negative button, 0.02 x squared plus x plus 6. So you notice I didn't type negative 0.02 because your calculator knows it's the same thing. But just always be watching for that right there, because sometimes students will put 0.002 and you're going to have a completely different graph. So go ahead and hit graph. And when you're looking at this right here, you're like, wait a second, this doesn't look like this. Well, this is because our graph isn't scaled appropriately. So first of all, when a person who's 6 feet tall throws a basketball up, do you think it's only going to go 10 feet away from them? No. So what I'm going to do is I can either zoom out. So if I want to do that, I can hit zoom and then I pick option 3, and remember that little blinking dot, and then you can zoom out wherever you would like. I'm just going to center it on 0, 0. And when I do that, I can see the path of the basketball, and there's the maximum right there. The other option that I have, should I still be in the standard mode, is to think about it and figure out my own window. So I know that basketballs, like right here, they're not going to be from a negative over here, so the x's are going to be 0. And it's probably going to go pretty far, so maybe I'll guess that it'll go like 50 feet away. And maybe I'll scale them by, I don't know, 5s. Sure, whatever. And then I also know that for the problem that I'm interested in, it's not going to go below the y-axis or the x-axis, so that's going to be 0. And I'm thinking, like, how high can he throw this basketball? I don't know, what, like 30 feet high, maybe? Who knows? And then maybe not that high. Maybe I'll scale that by 3 and just do 10% and then hit graph. Hey, that's pretty good. I maybe guessed a little high there, right? And maybe didn't guess far enough here, but what I'm interested in this point, so second calc. And then I need to find number 4. And then the way I'm going to tell that I'm to the left of my maximum is by watching my y values. So I'm going to start clearly to the left, and I'm going to hit enter, okay? And then how do I know when I'm to the right? So the way you're going to know is look at your y values. They're increasing, increasing, still increasing, still increasing. We're at 18.49, 18.5, oh, back to 18.49. Now I'm starting that descent, so I'm to the right, so I'm going to hit enter again, and then would you like me to guess? Yes, please, enter. So it says x is 25 and y is 18.5. The question asks me, what is the maximum height of the ball? So it's your job to interpret that point. Which number is it? So the answer is going to be 18.5 feet, because that is the maximum. It's the y value. And that's it for today on the graphing calculator.